Guys, welcome to 2.1. In this video, we're going to talk about the addition property of equality. Let's get started. Number one, it's and number two, and number three. You're really just trying to figure out. They're asking you, is this a linear function or is it not? All right, and that's really simple because you want the x and the y, or just the x, to have the power of one and nothing else. If it has the power of anything but one, it's not linear. So number one, because you have 7x to the first. Remember, if you see an x but you don't see an exponent, it's understood to be one. Okay, so because this is my only variable and it has an exponent of one, this is linear. Okay. On number two, I only have one variable, it's x. It is 2, which is greater than 1. So this is not linear or non-linear. Okay. Number three, you're not solving anything. Once again, you're trying to figure out, is this linear or is it not linear? All right. 2 was more obvious because it was, hey, this is x squared. 3 is not so obvious simply because it looks like x has one power, and you would be right, it does have a first power. But you have to also take into consideration that it's not just x in the first, it's not just x in the first, it's x in the first and the bottom of the fraction. Okay. Later in this class, we'll talk about negative exponents, but here's a quick rundown, right? I could rewrite this problem as 6x to the negative 1 equals 15. And that would take the negative of the x in the first and bring it out of the denominator and into the numerator. But when I do that, you can see I have a negative exponent of negative 1, right? That is not the same as positive 1, which means this thing is not linear, which is what I was trying to get to begin with. Is it linear? Is it not? Okay. Now, starting with number 4, we have this addition property of equality, which simply means whenever you add to one side, you add to the other. Whenever you subtract to one side, you subtract from the other. Okay. So here on number 4, I need to get z, or whatever the variable is, by itself. In this case, I'm going to go -1, -1. It is positive. I need to move it across the equal sign. So when I do that, I subtract. Anytime you go across that equal sign, you have to change the sign. If your terms are on the same side of the equal sign, it's just combining like terms, and that's not what we're doing right now. So this is going to be z equals -17. Okay. Now I have to remind you, sometimes Pearson, when you go to do your homework, they ask you to do the solution set, which simply means you're going to take -17, plug it into some braces, and that's what you have. That's your solution in a solution set. Okay. Now on number 5, do the same thing, but this time x is on the right side. Typically, when we're dealing with equal signs, I really just try to keep my x or my variable as a positive. So that will kind of determine which side of x I'm going to move it to, if I'm moving it at all. In this case, I'm not moving. It doesn't make any sense to move my x. So I'm going to add 16 to both sides, right? So like on number 4, it was a +1, so I subtracted. Here on number 5, 16 is already negative. So I'm going to add it to both sides because again, property of equality. Whatever you do to one side, you do to the other. All right. So x equals -5. Okay. Now, there are ways on number 6 that we can get rid of fractions altogether. But you also have to weigh that in consideration of like, is it going to take me longer to finish? Is it going to make my job easier? And you have to weigh that for yourself. But let's take a look at this. It's already adding 2/3 to the x. If I want to move it away from the x, I have to subtract it. So 8 minus 2 is 6, and 6/3 is an even whole number. So it doesn't make any sense at the moment to get rid of. It doesn't make any sense to get rid of the fractions. So let's do -2/3. -2/3. This is going to give me x is equal to 6/3. Now, if they were right now, it doesn't make sense because they're common denominators. If they didn't have common denominators, then it's a different conversation altogether. We might want to go ahead and get rid of fractions at that point. And here you have 6/3, which should be pretty straightforward. It's going to be 2. Okay. Like here on number 7, I have unlike denominators. So this might be a time for me to go ahead and get rid of it. So my common denominator would have been 10 because 10, 5 goes into 10. So that works. So this fraction does this thing and multiply the entire thing by what would have been my common denominator. And that's going to give me 10x. 10 goes into 10 one time, so 1 times 1 is 1. 5 goes into 10 2 times. 2 times 4 is 8. That's going to be -8. Okay, now we got rid of our fractions. Let's work. So I'm going to subtract 1 from both sides to get the 10x by itself. That's going to be -9. And then by now it was 10 times x. Again, I need to get x by itself. So I need to undo that multiplication, which is I'm going to divide. So I'm going to divide by 10 on both sides. That goes away. So x equals -9/10. If you had not gotten rid of the fractions to begin with, you would have to the same answer. So whether you choose to work with the fractions or not, it's up to you. you can get rid of them. Similarly, you can get rid of the decimals, right? But in this case, I'm not looking for common decimals or common denominators or anything like that. So it doesn't really make sense in this situation to get rid of the decimals. I can just go ahead and subtract 5.3, and x equals 1.2. It's very simple. There's no need to overcomplicate it. Yes, getting rid of fractions or decimals is a useful tool, but you need to know when to use that tool and when not to. In this case, that overcomplicates this problem to try to pull that tool out. So, right, number 9, you have, this is just an order of operations problem. You got, remember, if everything's on the same side, I'm just combining like terms. And so let's do that first. So when I have a string of numbers and string of terms like this, I like to mark up my problem and see where my like terms are. So I got x's here, here, and here. I got constant terms here and here and here. So let's bring these together. I got -7, plus 5, plus 3. Plus 5 and 3 is going to be 8, minus 7 is going to be 1, so it's going to be x. All right, so I got 7, positive 10, and 2. So 7 and 10 is 17, minus 2 is 15, so it's plus 15 equals. Okay, and then I got 2 times 5 on the other side. I got 10 less, it's going to be 12 plus 10. Okay, x plus 15 equals 22. X equals 7. Okay, so don't let a problem intimidate you. Just take it one chunk at a time and one step at a time. Work what you know in pieces, and then it will eventually be the end of the problem. You'll be done. We'll have an answer. Everything's great. All right, last problem here. If 15 is subtracted from a number, right? Notice this is subtracted from a number, so it's going to be x minus 15. That number could have been anything. It didn't have to be x, but it could have been. So you could pick any of the alphabet. I'm picking x. It says x. If 15 is subtracted from a number, the result is -4. So equals -4. And then it says find the number. If it didn't say find the number, you could potentially leave it, but it says find the number, so we got to solve for it. All right, so this is going to be plus 15 on both sides. All right, so it's going to be x equals 15 plus -4. It's going to be 15 minus 4, which is 11. Okay, that's it. It's 2.1. If you have any questions, please reach out, and I'll see you in the next video.